Hey everybody, Dr. A here, and in this video we're going to be providing some background information on non-right triangle trigonometry. So let's go ahead and get started. When a triangle is not a right triangle, the basic ratio definitions of the trig operations are not going to be applicable anymore. So what do I mean by that? Well, if you watched my other videos on right triangle trigonometry, what we found is we could define sine, cosine, tangent, secant, cosecant, cotangent based on ratios of the sides of a right triangle. Okay, so that's a triangle that one of the interior angles is 90 degrees. Well, what happens if you have a triangle that none of those interior angles are 90 degrees? Well, that's where we have what we call a non-right triangle. So if we want to relate side lengths to interior angles for non-right triangles, we use either the law of sines and or the law of cosines to make those relations. So let's go ahead and sketch an example of a non-right triangle to help us visualize that. Let's say that we have this triangle here, and none of these interior angles are going to be 90 degrees. Okay, so let's go ahead and do some color coding. I'm going to call this angle right here alpha, and I'm going to call the side that's the opposite of alpha side A. Okay, now let's call this little angle over here beta, and let's call the side that's opposite of beta side B. Okay, and let's call this third angle gamma, and I'm going to label the side that is opposite of gamma side C. Okay, and I'm color coding these for a reason, so we can see how this these law of sine and law of cosine relationships piece together. Okay, so again, this is a non-right triangle. So what would the law of sines tell us? Well, the law of sines tells us that the ratio of one side of a triangle, of a non-right triangle, to the sine of the opposite angle is going to be equal to, and I'm color coding these on purpose now, the ratio of a second side of that triangle to the sine of its opposite angle, which is also equal to the ratio of the third side of that triangle to the sine of its opposite angle. So let's take a look at that, okay? We're saying side A divided by sine of alpha is equal to side B divided by sine of beta. Notice beta is the angle that's opposite of side B, and that's equal to side C, the length of side C, divided by the sine of its opposite angle, gamma, okay? And so this is our basic law of sines. Now, here's what's really cool about this, okay? You can cross multiply all of these around each other, and we can restate this as the following. We could restate this as sine of alpha over A equals sine of beta over B equals sine of gamma over C. So you could use this law of sines relationship in both reciprocal senses. Remember, the word reciprocal means one over something. Both of these relationships are equally valid, okay? And again, I just did the color coding for convenience, so you can see how these sides and opposite angles are related to each other. So basically, if you have some of these pieces of information, you can solve for some of the other pieces of information, all within this non-right triangle. Now, here's what's really cool about law of sines, okay? If the triangle is a right triangle, law of sines will simplify to the basic ratio definition of sine. Okay, so here's what's cool. Law of sines, it really works on any triangle, even if it is a right triangle. It's just if you have a right triangle and you use the law of sines, it's just going to simplify down to your basic ratio definition of sine or cosecant, depending on which version you're using. Okay, so so that's something kind of handy to keep in mind, okay? What about this other thing called law of cosines? Let's write that down, okay? Let's write this down. Law of cosines. And again, I am referring to this same color-coded triangle that I drew already, okay? So here's how law of cosines relates things to each other, okay? So what law of cosines can say is that side A squared is going to equal to B squared plus C squared minus 2BC times the cosine of alpha. Okay, so one more time, you know, this seems kind of bulky. How can you remember this? Well, you can also go back to remembering opposite side and angle, okay? So side A squared, that's here in red, equals this formula, okay? And this last term of the formula has a cosine of alpha tacked onto it. So the A squared and the cosine of alpha are that opposite relationship, right? Opposite side compared to angle, okay? Also, if you notice, the first part of this relationship is pretty much a derivative, not derivative in the case of calculus, but it's a derivation of the Pythagorean theorem, okay? So what's cool about this is even though this looks kind of bulky, it still has a familiarity to it. Another pattern you can remember for law of cosines is these two terms that you're squaring and adding together are the terms that are multiplied together in this third piece, okay? So this is law of cosines. Now, what's also cool about this is this relationship works for all three sides and angles. So we can also say, and you could say B squared is equal to A squared plus C squared minus 2AC times cosine of beta, okay? So again, you don't have to memorize all of this, right? Because if you just remember a couple of pieces, then the rest will fall into place. Look at this version of it. How is this version a little different but still the same? Well, in the second version, we're saying side B, if you square it, it's going to be equal to the sum of the other two sides, A squared plus C squared, minus 2AC times the cosine of the angle that's opposite B, okay? So if you wanted to say this kind of very generically, you could say one of the sides squared is equal to the sum of the other two sides squared, right, minus 2 times the product of the other two sides, also times the cosine of the opposite angle. Okay, so that's how you could say that you know, if you wanted to say that in words, all right? Now, with that said, what's a third way I can write this? I could say, and C squared is equal to A squared plus B squared minus, oops, didn't mean to scroll there, minus 2AB cosine gamma, okay? Now, here's the other thing you want to be careful about. Remember your algebra, okay? When you're looking at the sum of each of these sides squared. Each of them is you square them first, then you add them together. So, you know, make a little note to yourself here so you don't break your algebra, okay? So, for example, you know, x squared plus y squared is not the same thing as x plus y quantity squared. So don't add these two sides together, then square it. You need to square them individually, then add them together. So be careful when you say it out loud. It can sound kind of confusing sometimes, okay? So that's our law of cosines. And guess what? The same little statement I made earlier is true, okay? For a right triangle, law of cosines also simplifies. Okay, so what's great about this is law of cosines, you can still use it for a right triangle. Now, you probably don't want to because it's extra work, okay? You can just use your basic right triangle trig ratios, which are simpler to you know, punch through in your calculator. But if you do have a right triangle, you can still use law of cosines. It'll just simplify it down, okay? Now, another note I want to make, really for polygons in general, because this could be relevant in these kind of problems, we can say we can also relate the interior angles of any closed polygon by the following. We could say the sum of the interior angles is equal to n minus 2 times 180 degrees, where n is the number of sides of the polygon. Okay, so so this little handy sentence right here works for all closed polygons. You know, triangles, squares, pentagons, hexagons, whatever. Okay, now for a triangle, let's write this down. For triangles, we'll say the sum of the interior angles equals, how many sides are in a triangle? 3. So you say 3 minus 2 times 180 degrees equals 180 degrees. Now, why am I writing this down and reminding us of this? Well, again, in a lot of application problems of law of sines and cosines, if you remember this handy little relationship here, then it can, you know, expedite your calculations when you are also using law of sines and cosines for a particular problem, okay? Well, hopefully you found this helpful. If you did, please hit like and subscribe and be on the lookout for other content like this, both in applications of mathematics and in engineering. Thanks for watching.